right, so here's your third and last page of notes for local linearity. You can either stop the video and take notes now or listen to me and then copy the notes, but listening to me will make things stick better in your head. Here we go. So in real life, people may not actually know what your equation is, right? Maybe I gather data like for 5 different times I've gathered how much distance something has traveled, and I only have this 5 pieces of data. I don't have a function. You'll be required to know how to do this. So if I only have data like that, you can approximate the slope of the tangent line at a particular xy pair. All right? So close your eyes, picture you have a graph, or you have the actual function. You can find your xy pair, yeah? You can find it using how we did in calculator in class. Look, if I have just data, guess what? I can have some xy pairs. So that part is taken care of, and the rest is business as usual. 3 ways of saying the same thing of what I want to do. I keep saying it because it's important, and it will be said in 3 different ways in class, so it's nice to link them. I either want the slope of the tangent line at 13, 20, which is the same thing as the instantaneous rate of change at 1320, which is the same thing as the velocity at 1320 if I'm talking about movement in a particular way, okay? So remember in class I said you want to get points really close to each other. So if I have data really close means, well, I want points that are as close as possible with the data that I'm given. So I can use 1320 and a second point, yeah, to find my slope of my secant line. So you're welcome to use 5 and you're welcome to use 15. You might think, well, 15 is closer to 13 than 5 is, and so maybe I should use that. The rest is basically what we've done, right? I've just visually shown you hypothetically what it could look like. It's my 2 points. I want to approximate the instantaneous rate of change, so I'm just finding slope, okay? And then be careful about your units. The 3 was the y, so it has to be feet over the bottom, which was seconds, so my units are feet per second, and that is an approximation of the instantaneous rate of change. All right, I highly recommend closing your notes, seeing if you remember what you did. What was the point? How would I do something? What does secant mean? What does tangent mean, etc.? And I will see you in class.